Take a close look at this visualization of a black hole. In the center sits a perfectly dark sphere, surrounded by a churning, brightly colored ring of superheated gas known as the accretion disk. Viewed from the side, this disk takes on a bizarre, double-humped shape. This happens because the black hole's extreme gravity warps the path of the light coming from the far side, bending those rays up and over the top so we can see the back of the disk as if it were folded upright. You'll also notice a stark difference in brightness. The gas in the disk is whipping around the center at nearly the speed of light. On the side moving toward us, the light waves are compressed, packing more energy and boosting its brightness, while on the side spinning away, the light stretches out and becomes noticeably dimmer. If we look past that massive asymmetrical halo, at the absolute edge of the central void, we can see a distinct, intensely bright, and incredibly thin circle of light. This inner ring is a completely separate optical phenomenon from the glowing gas of the accretion disk. Scientists call this the photon ring. This creates a strange paradox. A black hole's defining feature is a gravitational pull so intense that nothing can escape its grasp. How can a perfect stationary ring of light hover on the absolute edge of the abyss? This diagram illustrates how a black hole curves the grid-like fabric of spacetime. View gravity as a massive object, distorting the physical tracks of space. Light is forced to follow these invisible curved tracks, a path known as a geodesic. The accretion disk is a violently chaotic environment, constantly firing billions of photons in every possible direction into this severely curved environment. For the vast majority of these photons, there are two standard outcomes. If a light ray is angled slightly outward, it rides the curvature of space, breaks free of the gravitational pull, and travels out into the universe to reach our eyes. If a ray is angled too far inward, it is dragged too deeply into the curvature. It crosses the event horizon and is permanently lost. If these were the only two paths, escaping to the universe or falling into the void, the center would appear as a simple dark sphere. Accounting for that bright circle on the edge requires a highly specific third scenario. Between the safe zone and the point of no return lies an invisible physical boundary known as the photon sphere. Here, the extreme warping of space is perfectly balanced with the speed of light. When a light ray arrives at exactly the right angle, it gets caught in the black hole's grip, locked into a continuous circular orbit. The ring we observe represents photons that orbited briefly before slipping away from that trap and shooting toward our eyes. This diagram shows how gravitational lensing shifts light. The outer photon ring is light from the disk's underside, bent a half turn toward the observer. Inside are subrings formed by rays circling multiple times before escaping, creating progressively fainter bands of light. The photon ring is an extreme optical time-lapse of light trapped in a violent gravitational battle, endlessly circling the drain until it slips away. That razor-thin circle represents the absolute final transmission of light the universe allows before the point of no return. Because this ring is built from light rays gathered and looped from every possible direction, its geometry is perfectly symmetrical. No matter what angle you view the black hole from, the photon ring looks nearly identical and circular. The dark void inside this glowing boundary represents the black hole's shadow, an optical dark zone roughly twice the diameter of the actual event horizon. When astronomers finally captured real images of these structures, the results mirrored the math predicted decades earlier. The precise behavior of the photon ring validates Albert Einstein's theory of general relativity on a cosmic scale. Looking at that ring allows us to simultaneously see the front, the back, and the underside of the universe's most extreme environment, all projected together onto a single plane. The existence of the photon ring demonstrates that at the absolute extreme, gravity folds reality into a perfect, self-contained loop of light.